talk about XNA game development. It's geared towards building your first game, so it's an introduction, which probably makes sense. I think for a conference like Tech Ed, if I was at the Game Developers Conference, you'd probably have lots of game developers here. So that's probably my first question is, how many folks have published a game? All right, we got a few. And then how many folks have just kind of messed around with XNA? Got a few more. And I'm assuming everyone else is mostly Silverlight developers for the most part. Okay, great. So I have another session this afternoon. I'll just mention real quick, give myself a plug. It's at 3:15, and in that session I'm going to talk about mixing Silverlight with XNA graphics. So if that's an interest to you, definitely attend that one as well. But let's get this session kicked off right here. All right, so if you stay to the end, I have a secret question. It'll be related to my topic. And if you're the first one that I see and you have the answer, then you come up, fill out this little form with this magic pen. And then I keep this, make sure if you win, I get the bottom part, you keep the top part. And then you can go down to the Microsoft booth. And right across the Microsoft booth is the Expansys booth. And at that booth, you can redeem it for a free Windows Phone. So that's what we have going on today. So I'm very excited to share that. See, a few folks got your ball caps on. Make sure you're wearing your ball caps. And if they spot you, you can win a phone as well. So get on the booth and get a ball cap. All right, so this is the agenda we're going to cover today on Windows Phone 7. Again, it's going to be introductory. So if you've built a game previously, please bear with me. And we'll get started. So this is what we have to work with Windows Phone 7 today. Now, I just said Windows Phone 7 today, but really this is actually showing you the future as well. So with Windows Phone 7 Mango, which we announced at Mobile World Congress, that's going to release later this year. So that's the platform. And we've already talked about the Mango tools at Mix back in April. So you'll notice one thing on the sensors, there's Compass, which is in every Windows Phone 7 today, but it's not exposed to developers. In the Mango tools, it is exposed to developers. The Compass is exposed. And the other item on this slide is that a gyro is a new sensor that is being added to the Windows Phone hardware specification. So new Mango devices will include a gyro, which can help with things like augmented reality and those types of capabilities. The other thing I would point out is with Windows Phone 7 Mango, we'll call it, is that with the camera today, you can take pictures, but you can't capture video, or you can't use the camera viewfinder as like an augmented reality type thing. So with Mango, you're going to be able to do that. So I'll demonstrate some of that with XNA in my session this afternoon. But I just wanted to kind of cover that. Now, a few things that are exciting is that we're talking these devices do have DirectX 9 capabilities and compatibility. So if you think about it, DirectX 9 was the graphics, hardware for desktop systems just, 3 years ago, maybe 4 years ago. So, the platform includes a really powerful GPU and is very capable when it comes to 3D rendering. For this session, we're going to focus on 2D game development because, again, it's a beginner's thing to go through. 3D gaming in development is definitely a little bit more involved because you got additional access and a little bit more rendering and whatnot. So we're going to focus on 2D game development. Now, the important thing is I just laid out the hardware, and every Windows Phone 7 device supports those sensors. So I get this question all the time. I work with large media and entertainment companies to help bring their applications over to Windows Phone 7. And they're like, hey, which 3 devices should I test with? And I explain to them, say, hey, every time, you can just pick one. And if it works there, the API is the same, the SDK is the same, all the sensors are the same, et cetera. Your game should work on every phone. And if it doesn't, it's a bug. So that's a good thing for developers. Great performance for 3D. What I love about game development is that I'm not doing database development. So here's database development, probably everybody here. So game development is really fun and interesting to me because you're thinking about different types of problems. And one of them that you think about quite often with game development is performance. If you become a good game developer, you'll become a great regular developer because you will think about performance in everything you do. You'll think about am I generating garbage needlessly? And I'll try to point those things out when we're going through the code so that you can think about things you can think about. But that's one of the things that I really enjoy with game development. I've been playing with XNA framework since it came out first for the Zune device. It was just kind of cool. It's a small screen. You just feel that you can do something with it, right? Programming on a 1900 by 1000 size high definition display is kind of scary, right? You don't want to build Pong for an HD TV, right? You want lots of graphics and content. Whereas, for a smaller device, it's kind of fun and it's interesting, and it's a smaller screen. You feel you can get your arms wrapped around it. So this is the tool. It plugs right into Visual Studio. If you don't own a copy of Visual Studio, which I'm guessing most of you do, but if your friends don't or your child is interested and they want to play around, there's some great tutorials up at Visual Studio, Microsoft.com/Visual Studio /your-language/beginner to kind of help you get started. There's a free download for the tools. And what's great with the tools is that you can target Xbox, you can target the Windows desktop, and you can target Windows Phone, all from the same tool. And in fact, you can actually share your graphics and assets across those three platforms. With the hardware scaler, it's a really good hardware scaler, and it's present on both the Xbox and the phone. And of course, the desktop is an incredibly powerful machine these days with the GPUs capabilities that are there. So there's two profiles in XNA framework. One's called Reach and one's called High Def. Reach profile means that you don't write custom HSL shaders. So shaders are these little programs that you write that create really awesome and amazing effects. But what's great about the Reach profile and with XNA 4.0, which was released last year, but they really redid the platform and they really kind of upgraded it. The middle item there with the configurable effects pretty much makes shader type effects like water and smoke and rippling effects and those types of effects available to any developer through configuring these classes as opposed to trying to find the HSL to high-level shaded language, HLSL, to actually write it by hand. So it's a great tool. It's very, very capable. So with that background out of the way, the typical game is not event-driven. So most of us are probably used to event-driven development where you're writing code and you're writing code in event handlers, or you're writing code in a view model behind your code or whatnot. With the game loop, there's pretty much three main things. There's loading resources. There's kind of doing update. Like update would be like get input, make calculations, like apply velocity to objects, detect boundary conditions if you're on the edge of the screen for test criteria. And then give the user feedback. Was there a collision? And if there was a collision, you want to make it interesting by showing like an explosion or something like that. And then you kind of keep looping between this continuously. On Windows Phone, the game loop is pretty much hardwired at 30 frames per second. And the reason why it's hardwired at 30 frames per second is because the device itself, the screen, is hardwired at 30 frames per second. So you can make the game run at 60 frames per second, but you're only going to update the screen at 30 frames a second anyway. So why use that battery? That's kind of another interesting aspect, kind of related to performance, but being battery aware, just kind of thinking about using resources efficiently. So that's just one of the ways that the tools help you be efficient with utilization on the device and using battery. So this is the general game loop sort of explanation. Now, in XNA, the game loop, we're going to dive into some code here in a little bit, but we have an initialize method, we have a load content method, and then update and draw. Update and draw, try to execute at 30 frames per second. You kind of have a game time variable that you can track, and there's some things that when there's a game time, like is the game running slowly? Like is my update method running too long? Because if you think about it, 30 frames per second is like 0.003 milliseconds or something like that processing, or 33 milliseconds or something like that. So if you're running at 33 milliseconds per update call, it's a pretty long time in the computer processing time. But if you have 20 or 30 or 50 objects that you're all trying to update, handle input, do calculations for, it can bog down your game. So when you start dropping frames or performance starts to get bad, that's the first place to look. is am I taking too long in update? So that's the game loop for XNA. We'll look at it in code in just a bit. And here we are now. So let's go ahead and dive into Visual Studio. And we'll create a new project. So when you install XNA Game Studio, you'll get a new folder. So we'll say New Game, and we'll just call it Tech Ed Demo 1. All right. So yes, I do have the Mango tools installed. So we'll just go for 7.0 because that's what my phone is over there. All right. So I just created a new game. Now, at first, it's kind of intimidating because you're kind of used to Silverlight as a Silverlight developer. We have a big, robust, rich object model with text boxes and animations and data binding and all that kind of good stuff that you're used to having as a Silverlight developer. So for XNA, you're pretty much the person. You are the man or the woman that's going to get it done in terms of coding. So, and the way it works is you have the game class, and on the game class you have a graphics device manager, which you can do things to the graphics device manager. You can change the viewport size. So if you're who's an Angry Birds fan? Probably everybody. Probably played it a little bit here and there. All right, so in Angry Birds, you know how you have the viewport is bigger than the screen size, so you can adjust the viewport size with the graphics device manager object there. You can get the size of the screen and those types of things. You can apply kind of global effects to it. And then the other important variable that's declared is a sprite batch. So a sprite is just an image. So it's a 2D image, and you use the sprite batch to draw images to the screen. And so just you just kind of use that to help you kind of get along with doing development. We'll use it in just a second. And then the other item that's really important that the game class brings with you within XNA is this idea of a game content project. So if you look over here, I created one project, but notice I got two projects. So I got one for free. What a good deal. The second project is where you put your content. What's interesting about this is that for those who aren't a game developer or aren't familiar with it, when you're a C++ game developer, all your assets kind of sit in folders somewhere. And think of like Halo. I mean, massive amounts of developers, massive amount of content. So all your assets are sitting in folders somewhere. You take a 20-minute time to compile it, right? At least, maybe longer. So you compile it, you run your game, and it crashes because assets weren't in the right folder. So now you got to start over. You got to find the asset, do the build again, and hope that it gets past the next asset, right? It's a time-consuming effort. With XNA Game Studio, the content gets compiled and sort of identified at compile time. So C# compiles faster anyway. But if you say an asset is a model, like a 3D model, a .x or a .fbx file, but it's really an image and you just kind of misnamed it, it'll tell you that as a compile time bug. It'll say, hey, this isn't correct. So it really saves you time. And that's how you manage your content. And I'll show you that in more detail in a little bit. So the content manager is what you use to load your content. And then initialization makes sense. Load content method, you understand that. Unload. Now, you don't put anything in unload unless it's something unique. So an example of something unique would be if you're using accelerometer, which as on the phone, pretty much your input is accelerometer, and then touching the screen. So you got touch and input. So if you're doing accelerometer, one of the things you want to do in unload, or if you have any background threads or additional timers, is you want to turn them off. So those are resources that are managed resources, but they're not managed directly by the content manager. So you say, accelerometer.stop, right? You don't want to burn up that user's battery. And you turn off all your timers, et cetera, like you want to be. So you want to be battery aware. So that's where you can be battery aware in unload. And then the update method, which we talked about on the slide, handle input, do calculations, et cetera, and then draw. So let's get started building a quick little game here. And what I'm going to do is I'm going to open this folder in Explorer. So this is my content folder. I have another folder over here that has a few sprites on it, in it. So I'm just going to grab this folder. I'm going to drag it on over. Here we go. And now let's go back to my project. So I'm going to show hidden items. bring in the sprite folder, and I have my objects. So we'll just look at this a little bit real quick. So these are all images. I just named them all sprites. Background, it's not really, sometimes there's terminology we'll talk about a little bit, but like sprites, like things that move around, but I just threw it all in the same folder. But if you look down here on the properties for the asset name is background. So when you load, let me see, give me a little hand here. It's not going to go. All right. If you, let me make it a little wider. Oops, not happy with me. That's all right. So if you look here, the asset name is background. So that is the asset name you use to load it. So you never have the extension. You want to type the extension. It just feels better to type the extension. I'll show you in a second. Then there's a content importer and a content processor. It's all selected by default. XNA detects it for you, and 99.99% of the time it's going to get it right. But there are examples of custom importers and custom processors that can import like a custom format. If you're a big-time game developer, you have your own special format. You can write a processor to kind of bring it in XNA format. You essentially convert it into the standard XNA model. Or, XNA has standard, internal, compressed, optimized representations for all the major formats out there. And you can also have a custom processor. So an example of a custom processor is that, like little flip books you have when you're a kid, and you could you maybe buy them and you have instructions on like draw this, and then on page 2 draw this, and you flip it and it looks like a cartoon, and it's just kind of fascinating as a kid, and you're like making this dog run on the screen. So that's exactly how you do animation in 2D games. And there's a little sample, it's called a sprite sheet processor, that makes it super easy to just dump a bunch of individual images into a folder, and you read it in with a custom processor that takes the XML file, and it hooks all those into one sheet, and then you can use an index like 1, 2, 3, 4 to get to your images. So you just cycle through those images using an index 0 through 9, and then all of a sudden you have you have an animation happening. And I have a sample to show that to you that we'll show towards the end, but that's just a little quick summary. All right, so let's go ahead and write some code here. So I'm going to go to the top, and you kind of can guess from my names that what these things are. There's a background, so I'm going to probably paint the background as a cannon. There's some enemy spaceships, so we're going to declare a few textures. So texture 2D. Oh. I'm in the namespace area. Let me get inside the class. Go down here. Texture 2D. We'll say background texture. And then, so that's the background. Now we have a cannon, so we probably want to place it on the screen somewhere. So we're going to draw it, and we'll call that cannon texture. We're also going to give it a position. So that's, we'll say cannon position. And let's just say it's fixed for now. We're not going to, I have a full sample that implements all this, so we'll turn it into a full game. And then the last one we'll do is texture 2D for an enemy texture, and then a vector 2 for enemy position. Now, the enemy's probably going to move around, right? So we also need another vector. So use a vector class, which we'll explain in a couple of slides, so just bear with me. I just wanted to kind of show you real quick how easy it is to get started, and then we'll talk about it, and it should help you understand what's going on. Enemy velocity. So we declare a bunch of variables. We're kind of building a game, and there's a cannon and there's a cannibal on them, but we're not going to worry about that for now. We'll go through the full example, and I'll show you that. We just want to show you how to get some stuff onto the screen. So now we need to load content. So we have the background texture, and we have that content manager, the content object, which is a content manager type. It just exists off the game object. And we have a load type T. So load, we're going to say we're going to load a texture 2D, and then we're going to find it, and it's located. Remember, I added that content to my content project. So it's in the sprites folder. So we'll say sprites, and then we'll say background, because that's the asset name. Remember I was saying you're going to want to put the file extension there? And then we'll do the enemy texture, same thing. And a texture 2D just represents an image. That's all it is. We're just going to draw it on the screen. Same thing, no extension. Now we're going to initialize the enemy position, and we'll say it is, what's that? Oh, thank you. Thank you very much. Appreciate that. Save me some compile time errors. All right, and then the position, remember, was a vector. So we're going to initiate the position. We'll say new vector 2. So the screen, generally games are landscape mode. So the screen is 800 wide, and it's 480 tall. So I want the enemies to kind of fly in from the right and come left. So enemies flying in from the right, coming in from the right. So we're going to put it, maybe 830, so it's off screen, and maybe at like 240, so like in the middle of the screen, and it's going to kind of come in from right to left. So I'm going to initialize the vector. I'm going to give it the x. Now, x is across the top. So I'm going to give it the x. In this case, it's landscape mode. So we'll say 850. Actually, no, we'll put it on screen. We'll say 750 for now, right? Just so that you can kind of see it. And then the y, we'll say 240. And enemy velocity, we'll initialize it. Think of the velocity as pixels per frame that you're going to move it. So we'll say it's, we'll say new vector. Now we can make it, let's make it just like, we'll say, so we want to make it move across the screen. So we're going to make x -10, and we're going to make y 0. So this should move it in a straight line. Remember, x is across the top. Straight line, 10 pixels per frame in the opposite direction of the screen direction. So it's going to go from right to left. All right, so we kind of set that up. Oh, with the cannon, that's right. We want to be able to defend ourselves against the alien invaders. In the sprites directory. Thank you. Oh, yeah, thanks. Coding on the fly. It's a good time. Cannon. All right. Thanks for keeping me straight. All right, so I think that's everything we want to initialize. So let's go ahead down to draw. Let's just draw first. So I have some drawing code here. And we're going to say sprite batch. Remember I talked about the sprite batch a little bit. Dot. So you have lots of things we can do on sprite batch. Begin is the key one. That's what you need to do to get started. And then you can get at the graphics device for the sprite batch if you need it, and you can draw a string, and then you can just draw a sprite or to the screen. So we're just going to draw a sprite to the screen. So notice it's asking for a texture 2D. IntelliSense makes you an awesome game developer right away. So let's get that right, and then we need a rectangle. But we're not going to give it a rectangle. We're just going to give it a position. 0. So vector.0 is just a free static method. It's just a 0 vector. So it's going to place the upper left-hand corner of the image at the origin. So the origin of the image will be put at the origin on the screen. So we're looking at it. You'll see the origin of the screen up here. That's where the background's going to go. And then we'll just say color.white, which just kind of lets it render. And then one thing I forgot to do is, and you'll get errors if you do this, you got to do begin. You start at begin, and then you start a sprite batch.end. So what the sprite batch does is the sprite batch sets up the graphics hardware. You are on the metal. You're not in Silverlight playing with some, mamby-pamby object model. You are down there on the metal getting it done. So, when you do the sprite batch.begin, you're setting up the graphics device, the GPU. You're saying, hey, here comes a bunch of sprites. Draw them in the order that I give them to you by default. Composite them, put them into the back buffer, and then when I say end, bam, move that frame from the back buffer to the screen. And that's pretty much what the sprite batch is going to do for you. So we can, therefore, do this as well. Let's go ahead and draw the, I do got to position the cannon, but we'll do that in a second. We'll draw the enemy texture. So the enemy texture is not so simple as the background, right? The background, we're just slapping at the origin. It's the right size. It just works. So the enemy texture, we want to plot it at enemy position, because that's the vector 2 that we initialize for where it's going to start. And then we're going to update enemy position in the update method in just a second. All right, so let's go forward here. White. So it just renders, and there we go. So let's see if I got this right. We'll do it in the emulator real quick, so it makes it nice and easy. So you can see the spaceship. Now it's off the screen partly because I didn't, the enemy spaceship was drew it a little bit too far to the left, but I wanted to be able to see it so you knew that it's there. So we drew the background. We got the enemy spaceship. Let's go ahead and clean up a few things. Now, one thing I forgot to do with the cannon was I did not give it a position. Cannon position. So let me just do that. Did I made that one a capital C, didn't I? I did. New vector 2. And we'll put this one on the lower left-hand corner. So we'll say x of like 60, and we'll say 400. Let's see if that puts it about where we need to be. All right, so we're going to add the cannon. So again, the cannon's got to be within the sprite batch thing. So we'll say sprite batch dot draw, cannon texture, cannon position, color. Oh, thanks. Oh man, what's IntelliSense doing for me? Oh, I know what it was. See, I expected it to be lowercase because that was my convention, but I broke it. That's why naming conventions are good. They work. That was intentional. Just kidding. All right, so now let's run it real quick. Let's check it out. All right, so we have a cannon. Not quite exactly. I like to be a little bit more to the left, so we'll move it over to the left. And it's kind of laying. It's like a wilted flower. Just kind of laying there on the ground. It looks like it's been damaged, but you get the idea. So we'll say, let me just fix that real quick. So get it a little bit over. We'll say 20. 20 is probably better. Awesome. And we'll move this to 720, so we'll see it. Now, I'm not going to run it again. Now we're going to do a little, we're going to make it dynamic. We're going to move sprites. It's exciting. So we're going to say enemy position plus equals enemy velocity. So we just added code to our update method, doing these incredibly fascinating calculations to move our enemy spaceship across the screen. So let's go ahead and do that. There we go. So hey, we're moving sprites. You now know how to code a game. Session's over. Thank you very much for attending. Just kidding. We're not done yet. But now, so the spaceship's still going. I mean, it's going to go forever. It's like negative 1,000, negative 2,000, whatever it is. So it's just flying by. So we'll go back. And now, just some little fun things. It's kind of crazy, but let's say we want to pretend this is Mars. So we can make that red. And we'll run this real quick. So now we're in the red planet. Kind of scary, spooky, right? Need a little effect for free. Didn't cost us any money. And then finally, we'll show you, we can make the enemy like orange. That'll be really weird looking. Let's check it out. So you can do things like, dynamically change the color. All right. Oh, we just missed a sprite. Oh, man, got to fix that. Got a bug in my code. There we go. So it looks kind of crazy, but you get the idea. All right, so that's Game Development 101. We're going to switch back to slides, and we'll show you some more interesting samples. But you're now enabled, seriously. All right. So I talked about loading content. I'm just going to go through this. I talked about it being expensible and the compile time checking. So we kind of ran through that when I did the demo. So check the box. We're good. Any questions there? Go ahead and raise your hand. Any questions at all, feel free. And we saw this in the code when I was coding it. Now, you could do the double backslash. I always mess it up, so I generally do the front slash because it's just easier. All right. And then the update method. We saw the update method, how we did the incredibly complex calculation of adding two vectors together every frame to move the element across. But, we could add neat stuff like detecting the the boundary condition. We can do collision detection. It's really simple to do collision detection. I'll show you that code in a second. But you essentially take the two objects on screen. You grab a rectangle for their position and size. And then there's a rectangle dot intersect. So do these two rectangles intersect? If they intersect, you have basic collision detection. So you're done. So I'll show you that code in a second. But again, you really guys are going to be able to code a game when you're done here. And then render the scene we saw. So here's an example of, to do. And we got some, so we just saw this in the game development process where we're drawing sprites, moving them around. Now, as you can see though, if you had 30 objects, if you were doing that, if you were coding that the way I was coding this, right, it'd get kind of messy because you have tons of little properties. You could have little rotation and particle systems and make your sprites explode and things. So it would get really messy and redundant. So there's like 1,000 blog posts out there on like a game object class that you could use to build out your game to make it more object oriented. And that's really the way to go. And I'm going to show you a sample of that. But that's kind of the reason why I have that as one of the key steps. And then handling input, accelerometer, touch. So, and we showed this, these are kind of the lingo. Textures are generally background images or things that you apply to a 3D model. Sprites are things you move around. We saw the instantiation. So drawing sprites, we saw that. So this is a little example. Let's say we have an enemy object, game object. We'll say if enemy is alive, we only want to draw objects that are alive because otherwise the game would look funky if we blew something up and it kept going on. There would be no satisfaction of killing the enemy spaceships if they did not die. All right. And then we saw the Cartesian coordinate system. I talked about it. There's just a little picture that discusses it. Now, obviously, for 3D, the axes are flipped. And you would actually see a z-axis with positive z coming out of the screen and negative z going into the screen. So it makes it a little bit more complex. But for 2D, it's easy. Y going down, X going across. And what's great is that if you're doing a portrait game, maybe like a shooter where like a Space Invaders type of game where they're coming down from the top and it makes more sense to make it a portrait game, you can just tell the graphics device that, hey, I want a portrait game. And you don't have to do any additional math to like make the Y-axis now the X-axis and kind of flip everything around. The XNA takes care of that for you. So it's very clean that way. It makes life a lot easier. All right. And then we saw the moving objects where, in this example, the position vector is 10, 10, and then the velocity vector was 0, 10. So that means that the object that it was at 10, 10 would go straight down the screen at 10 pixels per frame. And same thing, and this just kind of like explains that a little bit further in the picture mode. But I always like to show it first and then talk about it, and then I think it definitely helps to go through it. So if there's any questions, feel free to ping me. So one of the things with vectors that you can do is you can change the magnitude of a vector just by multiplying it by a constant. So it's kind of a way of implementing levels or let your game get harder over time. So let's say it takes 5 points for every enemy object that you destroy. And when you get to 50, you can multiply the velocity vector by 2. And now the enemy ships would come in at twice the original speed. And then you could multiply it by 4 when it's like 100 or something to make the game more challenging and interesting as the user continues to play. Because that's how the game makers back in the day in the arcades made their money, right? You kept putting in quarters because it got harder. You wanted to get to that next level. That may be a reference that's a little old for some of you. But anyway, blew a lot of money in arcades. All right, so and we did this demo. So let me just jump over to game object. So we kind of get it. It's encapsulation. It's object-oriented. It makes life easier. It makes your code much cleaner. So you can do code like this in your update method, which, you could have a game object. There's kind of two implementations where you let the game object do all its own updating and drawing. It's very easy to implement. That's one way to do it. And another way to do it is have the object just kind of be a state manager and to do your update and drawing inside the main game application. That's the route I take here, just to make it a little bit more obvious. But as you can see, if you had enemies, maybe 10 enemies, that's another way to make your game harder. Increase the number of enemies that are coming at you over time, that type of thing. So, but in this little loop, you just kind of loop through your game objects and call update, and then the objects update themselves. All right, so let's go. Now what we're going to do here is I have a game sample that takes these assets that we've just been playing with, and it kind of implements a more full-featured version of the game. And what we'll do is we'll do this demo. There we go. I will do this demo on the phone. Okay. So I'm just going to run it, and I'm going to switch over to that screen. So you see the spaceships coming in, and I can tilt the game, and you can see remember that color thing I showed you? I showed it to you for a reason. And hey, look at that. See, it's a little tricky. You got to hit it right on the button, so it makes a little game action, a little fun. Got some cool explosions. Those explosions were free. Just grab them off of a sample on App Hub, which is one of the topics of this. One of the key takeaways from this project is that there's a ton of samples you just grab. It took me literally 20 minutes to add explosions to this. And you can modify it and customize it to make it fun. But you can kind of see we got a little bit of a game action. It's kind of interesting how you implement this. You really got to play with it. And like one of the things that was hard was like figuring out the touch target. So what I did was I had an extra texture that was a square, and wherever I touched, the square showed up. So it really helped me within like a minute guide my square in without graphing it and doing it the way you're supposed to do. Just kind of cheat it. So anyway, so that's a little sample of this. Now let's look at this in code. So we'll close all but this. So we're in the game loop, and essentially, let's go to update. Okay. Since you asked nicely. Thanks for saying please. I appreciate that. Just kidding. Sorry. I grew up in Philly, so please excuse me. All right. Because I had typed the D key in my code by mistake. So I fat-fingered my code a little bit. All righty. Let me just scroll on up here. So you see this is a decent amount of code here. So there's update. And again, I implemented this game, and I'll make sure it's available from TechEd so you'll be able to play with it and hunt around with it after the session. But here I'm just capturing the accelerometer input. Remember, the accelerometer was tilting the cannon. And one of the tricks that I kind of learned really quickly was to have like a no movement state. So like I initially had it like if it's greater than 0, then like swing the cannon way down, and then if it's less than 0, swing the cannon to the left as long as it's tilted. But then you're like constantly, the cannon's always moving. It was kind of hard to do shots, which may be part of the game action. Maybe your cannon gets disabled, and then it acts funky. But I have a little test in here that if the accelerometer is really small, the reading is really small on the y-axis, I just set the speed to 0. So that I can kind of set my cannon and shoot away. But it makes it really easy. So as the game advances, that would be like a gameplay option would be to make this number like smaller and smaller. So like when it gets really hard, you make it like 1. And we'll leave it at 1. And next time I run it, you'll see the cannon will be flying all over the place because it's really hard to stabilize. So again, it's a way of kind of messing around with that. Now we have rotation speed. And rotation is we apply the rotation to the swing when we're just rotating that sprite image. We just you can apply a rotation directly in spritebatch.draw. One of the parameters is a rotate, so it's super easy. It looks really fancy, but it's really pretty simple to do once you see it the first time. So what's that? Oh, float. I'm just making it a float. Yeah, sorry. So what I do, though, is I don't want the cannon to swing like way over 180 degrees or like swing into the ground. That wouldn't look nice. So I keep it between 0 and 90. And so we have this function called clamp and the math helper function. There's all these neat little math helpers that will do linear interpretation for you. Clamp. So clamp essentially keeps it between 0 and pi over 2. Which all angles in in XNA or in radians. So that's why you don't see the cannon speed or Kangle rotation being like 30 for 30 degrees, whatever. That's why it's like a small radian number. Because 0.3 would be roughly 10% of a circle, right? Because a circle would be pi, 2 pi, right? 0.3 would be 5% of a circle, so 5% of a rotation in radians. So that's where that's coming from. So clamp is helpful. And then the touch area. So this is the little touch area. That's the accelerometer, and then this is the touch input. So the touch panel in XNA is awesome. When I do input in Silverlight, I personally like to use the touch panel in XNA to do like gestures. If I need to do gesturing and read gestures, I just find the touch panel really easy to use. And that's one of the great features of Windows Phone 7 is that in today's model, you can call APIs from XNA in your Silverlight app. So in Silverlight, you can get to the microphone, you can get to the media player, you can get to the media library if you want to read the user's media library. And you can also get to the touch panel object, which gives you gestures. And I have a sample that shows gestures in a second. But right now I'm just getting touch points. And the thing that's interesting is that for every time the user touches the screen, you get 2 touch points. You get the press and the release. So when I initially did this, messing around, first time with Windows Phone, and actually way back with Zune, is I was firing twice every time I touched the screen, and then I realized I really need to ensure that I only, maybe only fire on the released event. So, it's like mouse down, key up, key down, mouse up, mouse down. Think of this, finger up, finger down. So that's where the fire cannonball occurs. And what we do is we have the cannon.touch area. So touch area is defined as a square that's the bottom part of the cannon. And I say .contain. So touch area is a type rectangle. So we just say, you basically define a rectangle, which is an X and Y point in the upper left-hand corner, and then a width and a height. And that rectangle becomes a touch area. And then you get the touch area for the touch point. Where do my finger touch? And then you see if they intersect. And if they intersect, then that means the user wants to fire a cannonball. And that's really that's pretty simple, really, to input basic touch into a 2D game. What's that? The speed of the cannonball, I input inside, if we go up top here, cannonballs. So let me see where I declare it. I can find it. It's probably in somewhere in. Oh, there we go. That's number of cannonballs, so you can fire 3 at a time. So you can only have 3 in flight at a time. So otherwise, the game would be too easy. Then I have a minimum angle and a max speed for rotation. And then I found all the references. Let's see. So I set cannon speed. That's cannonball. Cannonball speed we want. That's right. Thank you. Let me just get this here. Cannonball speed. I know it's in there, otherwise it wouldn't work. All right. Maybe not. Maybe I hard-coded it in there. Bad on me. We'll find it. It's in there somewhere. Let's go to fire cannonball. There we go. We'll go to the definition there, and we'll see. So this is kind of interesting because we want the cannonball to fly out. Oh, okay, so ball is a game object. See, I was looking at it from the old way where I had all the variables in the game class, but we have a cannonball object, and the cannonball object is a game object, which we'll look at in a second. And the game object has a velocity parameter that I initialize when I create the game object up. So that's why cannon speed wasn't defined, because I did it the right way. So, but this is interesting in firing this, right? Because you want the ball to come out at the end of the cannon. So you wouldn't want it to come, like if I just fired it, based on cannon position, it would be the upper left-hand corner of the cannon. So the cannon would be here, and the cannonball would kind of fly out in space. It wouldn't look like it was coming out at the middle of the cannon object, so it looks like it's coming out of the cannon. So we do a little math, just a little bit of cosine and sine to get the x and y for the rotation angle. So we get the cosine and y, the rotation angle, and then we just we take the velocity and we just multiply it by 5 to kind of get it out there. So I must have picked the variable and then 5 seemed better. And then we do the cannon position again, where cannon position equals the ball dot center plus we up the ball velocity. So let's go ahead, and it's a great segue. So let's go ahead and go to the definition for ball. And then let's go into the game object for definition of game object. So remember all that stuff that we were doing extraneously within the code itself. Here you can see that the game object, it kind of takes care of all that messiness for us. We got a sprite, which we know we need a sprite. We know we need a position. We are using rotation in this example because that's how we're rotating the cannon. And the ball needs has a velocity, and the enemy has a velocity. And then we have an alive. And the reason why we have an alive variable is if we destroy an enemy, you might be tempted to go like enemy equals null. But what did I just do there? I created garbage, thank you. So I just created garbage that I really don't need to create, right? Because I have a max of, I think, 10 enemies in the game, or maybe 5 enemies. So I just have the 5 same objects. I keep reusing them. So I set alive to false. And then when the update comes back around, it loops through the collection of enemy objects. And it says, oh, you're not alive. Let me randomly pick a position. There's I use a random. I multiply it by the height of the page. So if the random comes back at 0.75, then I'll just multiply that by 480, and that'll put the alien spaceship will fly in at, maybe what's 1/4 of that? So that'd be like 380. It would fly in at 360 from the top, and so that's how you kind of randomly position those items. So anyway, that's the way of why we use alive, is that we don't want to generate needless garbage. All right, so that's the class. And then this class is very simple. It's just a state class. Again, there are other game objects that update and draw themselves that can make your game code even cleaner. But I left it this way so you can kind of see everything in one place. I have another sample that has it that way. So that's kind of the way that and then drawing is pretty simple. We just come through and we say, draw the background texture just like before. We loop through our cannonballs, and if it's alive, we draw it on screen. So if the user touches, we get an intersection, we fire cannon, and we draw the cannonball at its current position. And remember, draws firing every 33 milliseconds, or 30 times a second. So that's what gives us the animation, that gives us the movement. And then we draw the cannon, and here with the cannon, notice the extra parameter. We give it a rotation. And then we give it a center that we want to rotate around. So that's how we just get the cannon to move. It's really all the code that took. And then we do the same thing for enemies. We loop through the enemies collection. We just say enemies.draw. So a little bit more work in this game, but be part of the download. You can play around with it. And then the last thing I do that I wanted to talk about here is drawString. So we have spritebatch.draw and then spritebatch.drawString. Now, in our content project, we declare a sprite font. So you just said right-click, File, New, add a new item, pick a sprite font. And then inside the sprite font file, you can pick the font name. So I picked the Windows Phone font, just a CGI UI, it's just kind of the default. I set the size to 24 pixels. You can modify spacing, whether you use kerning, whether it's bold. You can define the character set. For this, it defines pretty much all the ASCII characters that you might be interested in. And what XNA framework does is it takes this file and it generates a whole bunch of bitmaps for you that represents each character. So you can, if you know like you're going to use a font for just numbers, you should try to just define the range for just the number images, because that means there's that much less content that you generate. I mean, if you don't need A through Z, then just generate that font for that images. Now, and that's just for the English language. When Windows Phone supports Asian languages, there'll be many, many more fonts to support. So you can really start to kind of weigh your game down in terms of if you let it generate like every font in the character set. So just something to consider for performance. But that's how you draw screen. You just give it a position, and then it writes it out. So let's go ahead and we'll run it one more time, just kind of give you a seat. And I did modify the acceleration so we can kind of see how that affects it. We'll just give it a quick run. All right, so it's, yeah, so you can see it's kind of a little bit harder to get it to stop moving. Oh, geez, thanks. Thank you. There we go. So it's a little bit harder to move around. You can kind of see it shooting across. But so again, another way of just modifying gameplay is you can just play with those different values and have a lot of fun with it. Again, if you're database programming all week, it's kind of fun to do something that's a little bit different. All right, let's go back to slides. Let's go on. So we talked about the touch collection. Again, it's a great thing to use the touch panel within Silverlight as well. You can have the different states. Remember, each touch is 2 states. We showed accelerometer, how we were measuring it. It's generally a value less than 1. So if you peg the phone, if you turn the phone onto an axis and kind of have all the acceleration in one direction, it'll get close to 1. It can be a little inaccurate. It might be 0.9 or 0.7. That's why levels and those types of applications suggest calibrating the app so that the app can calibrate itself for your accelerometer. There's actually a real reason why to do that. But yeah, it'll be negative acceleration as well. Cool. All right, so we did, oh, that's right. I got a fun demo, just kind of run real quick. This demo, it'll be part of the code. I'll just run in the emulator to keep it simple. It uses the gesturing, and it's a great way to learn how to use the gesture support within XNA or Silverlight. So we'll run it on the emulator because it works just fine. So I broke out my fantastic graphic artistic capabilities in Paint, and I should be coming up. Come on. That's weird. There we go. Awesome. I don't know why it took a little while there. So here's my amazing drawing capabilities. Please snicker away, have fun at it. Laugh at me. Laugh with me. So what I do here is if I flick the guy down, he kind of bounces. Okay, I don't know why that came up. Must have clicked it. Or I can flick it in a random direction. And all this looks really complicated and wow, you have it bouncing, there's acceleration, there's deceleration. But it is so easy. When you do the gesture automatically gives you that acceleration. And so all I do is, as the gesture kind of flows and you get the next value for the status of the gesture, what that does is it slowly decelerates itself using its own custom, formula, whatever. And I basically add it to the position and just get this little guy kind of bouncing around like crazy. So, and you can see here as I can double tap and it'll read the drag complete. Now let me hit and run this inside of the emulator or on the device, because the one thing that is pretty cool is that if you need to do pinch zoom for a custom object, it gives you the values, the scale for the pinch zoom. And yeah, thanks. I just got to unlock this real quick. All right. There we go. Awesome. Yeah, it's a race to do the pin unlock. Okay, we're good. So I can grab my guy and I can see how I can kind of make him really big and small. It's an amazing effect that is really, really easy to use with the with the gesture support in XNA. So so I'll make sure that's part of the download as well. And once it gets too big, it's kind of hard to manipulate, but I can kind of get him a little bit bigger. And he kind of bounces around like crazy. Okay, cool. All righty. Let's go back to slides. So this is the last bit of my session. App Hub has an amazing amount of content available for developers to get up and running with the game. So there's a screen management sample. So I've just been showing you gameplay, right? But you need a menu, a high score, options, etc. That's a lot of coding in XNA. This is where Silverlight shines, right? You can lay out a menu and a high score in Silverlight, no problem, super easy. Come to my session this afternoon, you can see how you can do both together in one app. But We have a screen management sample in case you want to do it with all XNA. And then there's a sprite sheet sample, which I'm going to run here in a little bit. Particle system sounds complicated, but that's what generates the explosions and smoke. So even if you don't particularly understand how to create a particle system, you can grab that sample from App Hub, modify it a little bit, modify the image, customize it, and you can add explosions and whatnot to your game as well. And there's many, many more. So let me just go ahead and jump and show you one list sample. Remember, if you stay to the end, you can win a Windows Phone 7 device. And if you already have one, you can give one to a friend. Or you can make a friend and give the phone to a friend. All right. So let me, I'm going to run this one. Let me just show you this real quick. So the sprite, this example is, let me just go up here. This example uses a sprite sheet, and that's that flipbook example that I was kind of talking about before. Let me go to it. There we go. So there's two projects that I downloaded from the App Hub, the Sprite pipeline and Sprite runtime. The pipeline is that custom pipeline that you got to configure on the XML file to tell it, hey, go collect all these files and build me a sprite sheet. And then the runtime is what you add to your code to actually do the processing. But if you go inside of here, in the content, you'll see a background texture, and then you'll see a bunch of sprites. So if you look at this with icons, they don't show up because they're .tga, but they're just PNGs. And you see there's a hero ship 1 through 9, so there's 10. And there's 0 through 9 for missiles, so again, and then 0 through 9 for spaceship. So that's kind of my convention. Each sprite, each kind of object, each game object, we're really talking about a game object now that has multiple sprites that we animate over time to create an illusion of like rockets firing. And so we're going to rotate through those 10 images at over a period of time to create the effect. But it'd be really, to me, it'd be very tedious to draw these out on like a single piece of image. Like, to take one copy and then modify it. So I love being able to draw individual images, modify it, and then save it, and it's done. If I mess up the next one, if I mess up on number 10, I don't mess up my other 9, right? If I do something wrong with the image, I just build each individual image. But the reason why you use a sprite sheet is that if you work off of one gigantic sprite sheet and just move around, kind of think of a viewfinder, and move the viewfinder around that sprite sheet to capture your image over time, it's much more efficient for the graphics developer, and it really increases performance tremendously as opposed to loading a new sprite, unloading a sprite, loading a new sprite, unloading a sprite. We're keeping the same sprite sheet on graphics memory and just moving that viewport around. So all these individual images will be converted into, let me see, and make sure I open this with the right program. Windows Photo Viewer. So there's 10 alien spaceships there. There's 10 kind of hero ships. And then there's 10 little missiles in there. And I know I'm not the greatest artist in the world, but you get the idea. So what we're going to do is just animate through those pictures in code. And it's great because with the sprite sheet runtime, you do it by an index. You don't have to figure out those coordinates manually, which is awesome. All right, so let's just go ahead and run this. All right. So there we go. A little bit of animation. So now, so you can see here, even though I'm not the greatest artist, you can make a friend, find somebody who's a really good artist, get together. You know how to code games in XNA. Your friend can build awesome graphics, and together you could submit an app and, get an app in Marketplace, start making money. We have advertising control for XNA, so we have full advertising support for your games. If you're a little nervous about charging for a game, you can do the ad-supported model. And now with these samples, you'll know how to draw, how to do collision detection, how to do explosions, how to do animations. So you kind of get you started and get going. All right, so back to slides. So we just showed the demo. So takeaways. I hope today you realize I have a lot of fun with game development. I think you will too. It's a great way to just kind of restart and get yourself energized about coding again. if you're, and I love doing database design and development. I'm not digging anyone who does database for a living. I did it for many years myself, but you want something different, a little bit of challenge, up your coding skills. XNA is game development is a great way to do it, great way to get started. Submit it to Marketplace, show your friends, have a good time. And then again, use App Hub. It's a great resource. Now, any questions? If you have any questions, please go ahead and go to the microphone. It'd be great. No questions? Awesome. So related content, and then what we've all been waiting for. Let's give out a phone. All right. So it's kind of hard because we have people both sides of the room. I feel like I'm going to slate somebody. All right. So in my talk today, I talked about some ways of implementing your game and some of the ways that can help you do things. So remember when I was talking about the cannon and how the cannon would rotate? We wanted to keep it between certain values. What was the class and method name? This guy right here. Okay. You win. It's all Matakurmai. Thank you very much. Hey, thanks for attending my session. Hope you enjoyed it. Thank you. And if you have any questions afterwards, come on up.